Hello everyone, my name is Jean Petric, I am from Lancaster University, and today I will be presenting a paper which I co-authored with two other Lancaster University researchers, Dr. David Bowes and Professor Tracy Hall. So the title of the paper is BugVis, Commit Slicing for Fall Visualization, and first I will show you a little bit of the background to this project, then I will show you how BugVis is constructed, show you a live demonstration of the tool, and finally conclude with some use cases of BugVis. So understanding historical changes of code is a time-consuming process by its nature. So if a developer needs to change some code, they first need to understand what this code is doing, which regularly includes looking at the code that surrounds the code where changes need to be introduced. And in some cases, especially when we're talking about fixing faults, it's also very good to understand where this fault is coming from. So this requires looking at the history of code changes. So how we typically do fault fixes and how we typically look at the history of the code, we use commits, which offer a convenient look at the code history. However, commits can regularly be bundled up with other changes, such as refactorings. And existing visualization tools do not follow code faults throughout their history. However, fault code analysis is valuable to answer three important questions: where, when, and why was the fault inserted. And so far, and to the best of our knowledge, no visualization tool follows faults at the line level during their lifetime. So if we look at the existing tools, we can see that we have a range of different tools that either focus at different level of granularity than line level, or they focus on the line level, however not on faults. So if we look at the first two tools, which are BugMaps and Hatari, they work at the class, either at the class level or on the method level. Other tools which focus more on the line level, such as Chronos, Chronicler, and Azurite, they will look at the line level but not necessarily faults. And if we want to use these tools to look at faults, we will need to do extra work in terms of identifying where these faults are in the first place. So no existing line level tool which explicitly targets faulty lines exists at the moment, and of course tracks those lines back throughout the history. So the way the BugVis is constructed is from three major parts. The first one being linker, the second one line mapper, and the third one bug backtracker. So the linker is using information from two external sources, which are Git and bug database. In this case is Git, but it can be different version control systems. And bug database can be a range of different bug databases that I will be talking about soon. So the linker will combine these two information to create a database of fixed commits for a specific bug. And then line mapper and bug backtracker will be capable of identifying which lines are problematic or which lines introduce the fix to the fault, and then follow back these lines all the way through the history to identify which lines were involved in the fault, and it will differently signify which faults, which changes to code are because of faults, or which are just changes that happen during the evolution of a file. So in the case of the linker, it works with an external SSZ tool, and in this case SSZ is a quite famous algorithm, prominent algorithm that it's used in software fault prediction, which we have adjusted and also with the help of BugVis to follow renames of files and code chunk movements. So if there are any movements of code in a file, our improved version of SSZ algorithm can follow that. The other thing about BugVis is that it's flexible, so it can focus on any label from bug databases, so not necessarily bugs, but it can also be enhancements. Regular expression is modifiable, so it can be adjusted for commit messages. If somebody is focused on bugs, regular expression is going to include words such as fix or fixes, but it can also be adjusted for anything else. And currently it can support several different bug databases such as GitHub, Jira, Bugzilla, and XML. So I will now show you a demonstration of the tool, which I have here on the other screen, and I will lead you through how the tool actually works. So if you look at the first drop-down menu, you can see a list of bugs which are pulled from GitHub or a local cached file. The second drop-down menu will then, for a selected bug, show you which commits are involved in the fix, and then it will show you in the third drop-down, it will show you files that are in that commit. Finally, when all of this is selected, you will get a list of files throughout their history. And as you can see, there are different colors. Each indicates a different thing. So for example, the green identifies a line that was just introduced in this commit. The yellow one or orange one is showing changes to the file. And finally, the blue one here is indicating that the line that we are focused on, so the line that we clicked. So if you now click on line 30, we can see that all lines which are coming from the same source are selected throughout the history. So as you can see, it doesn't have to keep the same line because obviously one line was added in the new commit. So now you can see how each time when we click on a line, we can see in this case that there was no, this line didn't exist before, so it's not going to follow throughout the history, but it will follow the closest line. But now if we click on different lines, all the history is going to follow what we click in the current commit. If we scroll more down, we will see some other changes, which are additions. And as we can see now, for the first time, we also have a new sign which basically says that this change is likely to be the reason of a fault. And as we can see, these extra lines were added to fix the commit. The C indicates that this change happened in the fall, in the commit prior to the fall fix. And then we can follow all the way through the beginning of the file, where we can see that this line has existed ever since the file. So the fault itself was there when the file was first created. So as you can see, we can have a clear vision of following a particular fault fix throughout its history. So we have used BugVis in multiple different scenarios. So far it has been used to identify some bugs which were missed by Defect4J, which is a very popular bug database of manually extracted bugs. And if you look at the paper, you will see an example of bug 96 in Yoda time, which was not detected by manual inspection in Defect4J. However, BugVis enabled the identification of that fault. BugVis was also used to improve the SSD algorithm by visually tracking changes, as I showed you in the demo, and identify type of faults developers insert in the professional environment. We also plan to further evaluate BugVis for assisted manual inspection of faults in commercial and open source projects. Thank you very much. This is the list of references that were used in the paper. For a more complete list, you will need to look into the paper, and we are happy to accept any questions you may have. Thank you very much.